Hi, my name is Jeff Yurek. I'm Vice President of Marketing for Nanosys. Welcome to our booth.
And what's the big news here, the Display Week 2024?
Display Week 2024, the big news from the quantum dot side is this is the year of quantum dot electroluminescent quantum dots. There are 4 amazing demos of electroluminescent quantum dot displays here at Display Week.
I just saw one amazing one at TCL.
TCL's got one, they're doing inkjet printing. Samsung's doing an inkjet printed demo. Sharp back here has a photolithography patterned electroluminescent quantum dot demo using cadmium-free quantum dots. This is what those of us in the quantum dot industry have been waiting for a long time.
4 or 5 years ago when you did the first videos, you were talking about this stuff.
Right.
And now it's actually showing off.
Yeah, we were just showing you little glowing pixels, right? Now these are real displays, and we think we're in the sort of 2 to 3 year time frame before we really start to see commercial products coming out. So a really exciting time. Sharp this year announced a 100,000 hour blue quantum dot lifetime, right? And so the big holdup has been, can we get the blue to last long enough to make a real product?
I thought there was going to be just 100 hours.
No, 100,000 hours.
100,000, that means no problem.
Add 100 nits, right? So you want to get a little brighter, and it's to half brightness. So not totally a product spec yet, but really knocking on the door. Very, very close.
Is there some trick you can do by adding more blue pixels or something, and if they decay, then it lasts longer? Like, isn't that what they do with OLEDs?
With OLEDs, you might have like a tandem stack with 2 or 3 blue layers. You can also make the area of the pixel larger so you sort of get more light out for less current.
Is there some trick you can do with your what do you call it?
We call it NanoLED. You can also call it QD-OLED. Originally it was called QLED. So you'll see a bunch of different names as you walk around the show floor. We're gonna have to sort out the marketing aspect of that.
You need to call your friends and make a standard name.
We should. We should get everybody together and choose one.
Or maybe it's okay to have a bunch of names, right?
Yeah, sure.
Depends.
Yeah.
So what are you showing here?
So this is, and yeah, by the way, we don't have one of those displays to show because we only make the materials that go inside. So you got to go to those other booths. This is a demo that shows the speed advantage of quantum dots. You know, quantum dots are the fastest light-emitting phosphor material in the world, right? And for a long time, I thought that was just like a cool party trick, a cool kind of curiosity, like the fastest gun in the West, right? But we've come to understand, talking to creative professionals and to gamers especially, that there's real value in the speed of the light-emitting material in the display. So on the left, we're showing a competing technology called KSF phosphor. It's a potassium fluorosilicate material that's used to down-convert blue light into red. And it has a nice, good, deep red color, but it takes 30 milliseconds to warm up and to cool down when it's exposed to light. And so if you look closely here, I'm not sure your camera will pick this up, but you see the red lights, the red color separating out of the white.
Yeah, with my eyes, I see a lot of red here.
Right, it's the result of that slow phosphor ringing after the pixel goes by. And here on the right-hand side, you have QDEF, and you don't see any of that artifact. So we developed a great test pattern that shows this effect. And then we worked with Mark Rahan of Blurbusters to develop these photodiode testers, and you're able to see on the oscilloscope the actual result of what your eye is seeing. And so you can see here the slow ramp of that red, and that's the red color warming up. And you see the green and the blue have some curve to them also. That's the slow opening time of the LCD shutter, but the red is much steeper. And then after the frame closes, look at how the red is ringing afterwards and just has this long tail. And if you look at the quantum dot display, it's essentially perfect square wave, again, with a little of that LCD shutter effect.
It looks like a skyscraper.
Yeah, and so if that's not enough to convince you, we have here on the left a piece of the KSF film and then a piece of quantum dot film. And you'll see as I move this around, you might notice there's a little red comet tail behind the blue light. And on the QD side, nothing. So you can go back and forth and really see the difference. So this is what's going on in your backlight. When you have a KSF with a mini LED backlight, or even a global dimming thing with a black frame insertion, that can be an issue. And so we're really excited to get a People's Choice Award here for the best metrology demo at Display Week for this whole demonstration. So I want to thank Blurbusters for helping us out. And Ian, who's right behind you, did a ton of work on this and did a great job pulling it together.
Metrology, It's got nothing to do with the weather, right?
No,
No?
no. Measuring the displays and capturing the performance of the displays and quantifying it. So important for reviewers and consumers, and the people developing the displays need to be able to quantify the performance difference.
So how successful has it been, the quantum dot business in the last few years?
Quantum dot business is doing great. So there's been over 1,000 products launched with quantum dots inside, tens of millions of units shipped, and we see a really bright future ahead with really continued growth. And it's a great place to stop. Can kind of look at our roadmap and talk about how that's going. So quantum dot enhancement film, that's the film technology that goes in LCDs. That's been around since 2013, and it's still growing and doing really, really well. We have a new version of that called XQDF, and this is a diffuser plate component. It's an extruded, air-stable version of the technology that doesn't need any barrier layer, so it's a lower-cost solution. So this is entering into a lot of TVs, and bringing quantum dot performance into a more accessible market.
How does it compare to quality here and here?
Oh, very, very similar performance. The top one has a little bit better performance, and so for really high performance sets, you probably go with this. But if you want a more budget-friendly set, this gives you almost all the performance.
How do you develop the more budget-friendly technology?
So the big thing for quantum dots is that they need some protection from oxygen and moisture, right? And so that's what we needed in the early days, especially a relatively expensive barrier film to protect the quantum dots. We improved the stability of the dots year over year continuously, so we can use lower and lower strength barrier films, and that lowers the cost of the solution. We're still paying for those extra plastic sheets. In this case, we developed a local protection for the quantum dots, so they don't need those barrier layers, and they can just be extruded right into this plastic diffuser plate component that just replaces the existing component in the display. It's a really great low-cost solution.
Because in the first few years, I was a little bit worried about price on the quantum dot TVs compared to cheap, let's say, more affordable TVs.
Yeah.
But now it nearly makes no sense not to get the quantum dot. Even the more affordable ones have it, right?
Yeah, we'll show you around the corner. $500 TV with this diffuser plate component in it. It looks awesome. So it's a great solution for every kind of price range. And now we have quantum dot OLED on the market too. This is a new version of the technology that uses a blue OLED stack. This is where we're talking about multiple blue OLED layers, can have 3 blue OLED layers in there, and inkjet printed quantum dots on the front of the display, making the red and green light. This has been commercialized as QD-OLED. It's in monitors, it's in TVs, it's winning tons of awards. It's amazing image quality. Perfect black, super bright, perfect color.
That's what people are saying. This is the best quality TV in the world right now.
I agree. Yep, absolutely.
That's what some people say, right?
Yeah.
The experts say that.
The experts say. You can go look at the reviews. Don't take my word for it. But yeah.
So does that mean there's going to be something even better coming out later?
Yeah, so there's a lot of headroom for that to grow. And so one of the cool things is OLED is continuing to improve also, right? So you're talking about now fluorescent, phosphorescent blue OLED, TADF, photolithography patterned OLED. There's a lot of exciting developments coming to OLED that can actually benefit the quantum dot OLED as well.
How about the idea of tandem?
Yeah, that's what this is actually.
That's using the tandem.
Yeah,
to get the more brightness.
Right, it's using 3 layers, so not just 2, actually 3 or 4 layers of OLED stack in behind the quantum.
Is it because the OLED has like space between the pixels that you can tandemize them to increase the amount of them or somehow?
It's not
a
space kind of horizontally. It's stacked up vertically. So each pixel has 3 layers of blue OLED behind it, underneath it, that are producing the light.
Nice. So you can have 2 and even more 3 tandems.
Yeah.
Right.
Now you'd rather have less, it would be lower cost. And that's why some of the advancements that are coming to OLED with improved blue performance, now maybe you have 2 and you can have brighter, or you could have 3 and have extreme brightness. So you get more flexibility in the sort of, product that you want to design, the performance that you want.
And the OLED, did they have some challenges in the blue and they figured it out?
They, I would say, have not totally figured it out yet. There's always more improvement to do, right? And so, blue OLED has just been a continual place for improvement within our industry for a long time.
Since the Middle Ages, blue has always been more difficult.
The Middle Ages, I guess, that's probably true. Even pigments.
The painters had the trouble to get their blue.
Absolutely right.
That's what I saw in some Netflix documentary.
Sure. Yeah, purple colors and things like that historically have been challenging too. Yeah.
Is this next NanoLED
NanoLED, so this is the electroluminescent. We already talked a little bit about this, but this is the ultimate display technology, we think. So what, you heard a lot about OLED, right? OLED is very challenging to make because it's an organic light emitting device, and it needs to be made in a vacuum to protect it, right? So making a display in a vacuum is very costly. Another electroluminescent device that people are really excited about is micro-LED. But micro-LED has a lot of manufacturing challenges. You need to make the pixels, dice them up, pick and place them. Even if you're at 5 nines of yield, you still have a lot of dead pixels, right? So it's very costly and challenging. Quantum dots are inorganic, semiconductor, light-emitting devices that are solution processed. You can make them devices in air. You don't need pick and place. You don't need all this challenging manufacturing. You can inkjet print. That's what Samsung and TCL are showing. You can photolithography print. That's what Sharp is showing. And you can make a much simpler, much lower cost, and still very high performance device.
Print. That's like the dream.
That's the dream.
You get a printer and boom, you get an amazing display.
Only put down the material you need and nothing else.
You still need the back, what do you call it?
You need the back plane, all of that stuff.
That needs masks and stuff on the back plane?
Yep.
Is there any invention you can do over there also? Some people do to make it more affordable?
So what some people are talking about doing is using pretty standard LCD equipment to manufacture this kind of display. That's what's super exciting because there's a ton of installed CapEx for LCD. So if you can take some of those techniques and make a display with this level of performance, that'd be just an amazing
Which part of the LCD stack goes in there? The backplane stuff?
Yep, you need a backplane, you need a high mobility black backplane, just like any emissive display.
Some talk about it.
What's that?
There's talk about it in the industry to get there.
Oh yeah, absolutely. Yeah.
Right.
Yeah.
Cool. Does that enable huge displays also? That's a question of
huge displays. So
fab generations and stuff like that.
That is a question of fab generations and also the technique that you use to make the display. So if you're doing inkjet printing, you can only go so small with your pixels, right? So if you want super high resolution, smaller displays, you want to use photolithography. But photolithography scales from the tiniest single micron pixel all the way up to 115-inch TV. 128-inch, I think, is the biggest you can do on a Gen 10.5 fab realistically today. And photolithography is doing that now. So there's different techniques, different pluses and minuses to each one, but yeah.
I like the micro LED tiles system. Is there any tiling that can be done with a NanoLED?
Don't need to.
Don't need to. Just make a huge.
Just print it.
110 max.
128.
128 maybe.
Yeah.
Depends on the size of the printer also. Or
yes. Yeah.
Can you just print in stripes?
I guess so.
I don't know.
You have to think about that one, but yeah.
Okay. Cool.
So next up here, we just talked about QD-OLED, and we're showing another kind of metrology demo where we're highlighting the advantages of quantum dot OLED. And the big advantage of quantum dot OLED is it has amazing color reproduction capability. So this on the right is a Dell Alienware QD-OLED monitor. It's a 31.6-inch 4K monitor, and it's got great performance. 98% P3 coverage, and it's 1,000 nits peak white. The special thing about the QD-OLED is it's also 1,000 nits of color. If you add the red, green, and blue colors together, you also get 1,000 nits. The signal that comes into the monitor is made up of red, green, and blue. And so this set is able to reproduce accurately the red, green, blue signal. This is a white OLED display, and you might notice the sun here appears a little bit more greenish than on the QD-OLED. And that's because it's using a white subpixel. It has red, green, blue, and white subpixels. And it's mixing in white to boost the luminance. This set, if you took a measurement of it, on the white, it's 1,080 nits. So you go, hey, it's actually a little brighter than the QD-OLED, right? That sounds great. But if you look at the RGB luminance, it's only 400 nits. So this set is only 400 nits of color. And so when you have a bright sunset scene like this, the monitor needs to make a decision. Do I respect the color of the sun or the brightness? And here it's choosing to respect the brightness, the luminance of it, right? It's using that white subpixel, which doesn't have color. And so that's why it appears greenish white. We're also showing here a new kind of metrology developed by Kenichiro Masaoka of NHK. And see if I can back this video up here. does this amazing trick where he gathers 602 data points from the display, and we're showing a sped up version of it here. He does it in 1 minute, by the way. So we measured both of these displays, and you can see it printing these little dots down, showing each measurement of the color capability of the display. The white OLED volume is a little spikier and skinnier. The QD-OLED, you can see it's a little fatter, but it's hard to look at that 3D representation. So he developed this, what's called gamut rings. And gamut rings takes a 2D projection of the C-Lab color gamut volume, and each little ring is an L-star 10 step. The way that the C-Lab volume works is it goes from 0 to 100 in L-star luminance. And so that's near black and that's bright at the edges. And what you want to see is the colored area is the measured display. And so here, the QD-OLED, the gray is the standard, which is BT 2020, and the colored area is the measured display. So the QD-OLED is actually filling up the standard. It actually covers 78% of the standard. The white OLED, you can see as it gets brighter, you see more and more gray. And that's because that's the white subpixel. It's not showing color at the high luminance area. It's only showing kind of black and white.
So there's a bunch new monitors that are great on the market.
There's a bunch of new monitors that are great. These are great consumer products. We also have an amazing professional reference monitor from
Is this
Small
the best
HD.
display at the Display Week?
Might be. It's super high performance display. So also 1,000 nits, effectively 100% P3, 99% P3, 4K, 31.6 inch. And Small HD does an amazing job pulling all the performance out of this panel. It's actually the same panel that's in this Dell here, right?
Is it super expensive or Small HD? I buy some accessories by them, no?
Sure.
It's not too expensive, but is this expensive? It's not like one of these $30,000.
So it's not 30, it's 13,000, right?
Okay.
So it depends on who you ask. For a consumer product, that's pretty expensive. But if you're in a professional production environment,
Color grading at Hollywood.
It's a super powerful tool at a very reasonable price for
because
that market.
the what do you call it, the professional Alexa guys and stuff, they need one of these monitors, and it can cost a bunch more than that, right?
A bunch more, yep. So it's great. And it's super rugged. It's got the handle. It's made from one piece of aluminum. Really, really cool, amazing product. Super accurate.
Nice.
So walking around here, this is where we can go TV shopping. This is a really cool demo that we did with ratings.com. And so we're looking at here 3 quantum dot TVs. And these are from their spring 2024 review roundup. And so these are some of the, according to ratings, best TVs of spring 2024. QD-OLED from Sony, best home theater TV. This is what you're saying. A lot of people say it's the best. Ratings calls it the best home theater TV. Here you have and it's quantum dot OLED. Here you have a Sony X93L. They said this is the best bright room TV for spring 2024. And it's using cadmium-free quantum dot enhancement film inside. Amazing brightness, amazing performance with a great mini LED backlight. It's about $1,700. A95L, of course, about $3,300. And then down here, you've got the Hisense U6K. And this uses that XQDF diffuser plate component that I talked about earlier. And this is only $550. Hisense Ratings calls it their best budget TV for spring 2024. So quantum dots have great solutions for all these different price points across the market. Whether you're in the market for more of a budget-friendly TV that's with great performance, or you want something with a little more horsepower here in the Sony, or you want the absolute best home theater experience on the market.
So I have one of these previous generation Sonys, and I wonder if the trick that they have is just excellent processing of the image and upscaling and all this kind of processing. They have a great algorithm. Is it part of the why they're great?
Absolutely, yeah. The Sony algorithm, the processor that's in this, both of these TVs actually, is really good. And motion is one of the areas that I see it the most. The way that they handle motion is really spectacular on these TVs. Of course, the color and the brightness from the QD-OLED part of it is awesome too.
So to have the best TV, you need to combine the materials, great components and stuff,
Yeah.
but also amazing AI kind of engines
Yeah.
and stuff.
Yeah.
That's how you get the best product, right?
It all has to come together. And we're living in a really golden age of TV performance. I mean, all three of these are just amazing, right? The floor has come up so high. And so, yeah, if you want to make the best of the best, you really have to be pushing the best materials, the best technologies, the best processing, right? All of it has to come together.
But could you push back a little bit on what I said in terms of what other things do you think Sony might be doing to help get this amazing quality?
To me, it's you've got a great QD-OLED panel, and then you do everything you can to pull all of the performance out of it that you can. Just like the small HD monitor, right? They took that and they tuned it up, made it super color accurate, and delivered a great experience. Sony's doing the same thing, right? It comes out of the factory with great color accuracy, great tuning, and amazing processing capabilities.
Calibrated in an amazing way somehow.
Yeah.
You don't need to sit and try to calibrate it yourself.
Yeah.
Right.
Yeah.
And I guess the processing on those latest Hisense is also just amazing, right?
It's really good, man. Yeah, these are, a lot of people coming. What I've found really fascinating, and my one regret for this display week is that I didn't set up a voting system. But sort of anecdotally, a lot of people are coming and saying, I kind of like this, right? Because it's so much less expensive and it looks really good.
You don't want to do a blind test.
Right. We can't do a blind test, right? But
yeah.
maybe if you
like
hit the price, maybe
the price would show up
reaction.
after you give you a result.
Vote. Yeah, exactly. So.
Oh, they could what do you call it? Some kind of mix them up in the back. Okay, for next time.
Yeah, that's been one of the trends we see in the marketplace too. QD-OLED's doing great, but we also see a lot of growth in mini LED and LCD because consumers love the low cost and they love that they can get a huge TV for a relatively good price.
One difference I see between those two is this one seems more or less reflective.
Yeah.
Is that like a layer on the front?
Yeah, they all have different kind of anti-reflective coatings. And the Sony does have a really good anti-reflective coating. And from this angle, you can see the QD-OLED has outrageous viewing angle, right? If you come all the way over here, it just doesn't give up, right?
It's amazing.
Absolutely incredible.
Awesome. All right.
Yeah, we have one.
And even the QD-OLED prices are getting great, right?
Yeah.
The prices coming to some affordable areas.
Yeah, especially when you think back 5 or 10 years, what a TV at the highest level would cost, right? It's amazing value. So this is our brand new quantum dot factory in Hiroshima, Japan. Nanosys was acquired by Shoei Chemical in September 2023. And these guys built an amazing new factory in Hiroshima. It's the largest quantum dot factory in the world. Construction completed in December. Operation started in January of 2024, and the first qualification runs happened in March of 2024. It's pretty wild. They actually built the inside of the building and the outside of the building at the same time. So when they finished with the outside, they were ready to start making the qualification runs. So capacity in here for 40 million quantum dot TVs. Again, largest quantum dot facility in the world. And really exciting to see that come online and start producing quantum dots. For
the largest nano production in the world.
Quantum dot specifically.
Is there other nano stuff that's in bigger quantities?
Good question. I don't know the answer.
Can't
so
say, yeah.
Maybe. I don't want to make any claims.
All right, and it's to make great nano quantum dot materials, it's a question of purification and stuff like that. You have to purify the materials, make them great, or to have the best quality. What
you want to do is you want to make them great from the very beginning. And I don't know if you were here on Monday or if you saw the keynote sessions. Professor Munji Boendi, the Nobel laureate for chemistry for quantum dots, gave a great talk, and he showed the way that his innovation in the synthesis of quantum dots. And that's what's really enabled this industry to go. He had a brilliant idea and a way to make quantum dots very simply. And he showed the small flask that they use to make the quantum dots in. And you put the precursors in, you have heat, you have time, and you stop the reaction when the quantum dots grow to the right size for the color that you want. And he's showing a little pipette where they're taking the dots out and sampling them as they change color. We do things a little bit more automation, a little bit fancier than that today, but basically the same process. And inside this factory are 3,000 liter reactors making quantum dots. It's absolutely amazing scale. And so you went from the 1990s, from the little glass flask, all the way up. And but essentially the same process that he talked about. So really amazing innovation.
Did you have a party on the announcement date of the Nobel Prize?
Oh, I think, so all the quantum dot people
company,
here at the show, internally for Nanosys and all of us.
Champagne?
It was a big boost for all of us.
Was that a surprise?
Yeah.
Or it was like maybe rumors or something for a bunch of years?
I wasn't plugged in enough to get any rumors. I was genuinely surprised, and I think the others in the quantum dot industry were too. You know, we all thought that there's a very good possibility of a Nobel Prize in this area because it was so important. But if you'd asked me, I probably would have said maybe 5 or 10 years from now, right? But I think what swayed the Nobel Committee was the commercialization, the impact of the technology on consumers and some of the new areas that are emerging where we can use quantum dots in agriculture maybe to help grow plants and grow food more efficiently, solar and different other applications that are going to be really beneficial, biological applications, et cetera. So I think that's what kind of pushed the Nobel Committee to move a little faster.
To make the world a better place, you need to have more people out of the 8 billion who can afford this stuff.
Yeah.
And you're helping get the stuff to billions more people actually.
Hopefully billions. We're in the tens of millions now.
Tens of millions,
but yes. Yeah.
But there's a billion people looking at it and saying that's 550 is not too far, it's not too crazy.
Oh yeah.
For many people. And the next couple of years is going to be even more affordable.
Yep.
And hopefully these huge companies who invested, I don't know, 20 billion and all this stuff in these LCD factories and fabs and everything, hopefully they can sell as many they wish to sell. This, the market, how is it going?
Interesting things about LCD, right? LCD has just been a very resilient technology, right? It's very hard to kill because you have these huge depreciated fabs that are massive scale in place. And so if you bring in new technology and you have to scale it up to replace that, it's very challenging. So yeah, there is definitely an aspect of that where it's great to have that LCD capacity and to make good use of it.
So this guy, what does he think about Nanosys?
Well, he came by the booth and did a great tour. Actually visited with us earlier this week, and the team was just so inspired to get to see him.
Did he visit before at the office?
Yeah, well, he was a scientific advisor to Nanosys. So in the early days, 2004, 2002 to 2004, I think.
Where is this?
He was, that would have been down here before Jason joined. And Lou Bruce, the other Nobel laureate, Bowendi worked in Bruce's lab and also won the Nobel Prize. He really discovered the kind of modern, quantum dot that we have today. He was an advisor to Nanosys as well.
All right.
Here we have Dr. Alvasados.
QD-OLED.
Yeah, this is a paper on QD, emissive quantum dots by Dr. Alvasados.
So it's been going on for this long?
Yeah.
30 years.
Totally, yeah. 1982, Bruce discovers it. Ekimov was around the same time, maybe a year before, in the Soviet Union. He won the Nobel Prize as well. We weren't as aware of his work here in the US. Now we recognize it. And Bowendi's was a grad student of Bruce's, had this synthesis breakthrough in 1993. And that's, again, the essentially same process we use today. And that's how meaningful that innovation was.
That's awesome. So this photo could have been taken back then.
It totally could have, yeah.
And he was showing in his slide hundreds and hundreds of students been working on doing a bunch of stuff in this area later, right?
Yeah, yep.
And then we come down, and he was also speaking.
Yeah.
Your former CEO.
Former CEO. He joined Nanosys in 2008. And a lot of development work had gone on leading up to 2008. Nanosys was founded in 2001, licensed IP and patents from Bowendi, from Alvasados, from UC Berkeley, from all over the world. And the idea was to commercialize quantum dots. And we kept developing the material, but it was challenging to get it into real products. You would go into a Samsung and show them, look, we made this great material. Let's put it in a display. And they would say, it's not our job, to figure that out. We don't want to do that, right? Make us do it, right? And so Jason came into Nanosys with the real product commercialization background. He's really a product guy. And so he helped develop the optical mouse, for example, at HP. And he brought that kind of mindset to Nanosys. And he really focused us in on developing a component that the industry could use to implement the technology easily, and to do so in a way that doesn't change the manufacturing process for display making. Our first idea was to use, we called quantum rail, a glass tube that went on the edge of the light guide. We thought this was so brilliant. We said it's a drop-in thing. You just drop it in the display between the LED and the panel. And the display making industry gave us some feedback on that, which was no, right? I need an extra tool in my fab to put that in. I think I need to use index matching glue to line it up. I don't want to do anything I'm not doing today, right? I already have my fab, I'm not changing it. So we thought we were pretty cool, we figured it out. Okay, back to the drawing board. And that's when we developed the quantum dot enhancement film. And that became a truly drop-in replacement. We first showed it here at SID in 2011. My colleague Zheng Sheng and I over here and I rented a minivan. We drove down this 47-inch TV that we modified with quantum dot film. And we built that film on our own coating line in Cleveland, Ohio. And the goal was to get 3M's attention, and we sure did. So after that, 3M jumped in, and they started to make quantum dot enhancement film. We started showing some of that film in SID 2012, and then in 2013, we won our first product, the Amazon Kindle Fire HDX7. And that was the first quantum dot enhancement film product. And so that was over 10 years ago. And it's been off to the races since then. First heavy metal free quantum dot TVs, cadmium free in 2015. First monitors here, 4K in 2016. First quantum dot and OLED demonstrated in 2017. So you're starting to get a sense of the timeline, right? Materials development.
That's when we did the first video make.
Probably. It's really hard, right? It takes a lot of effort and a lot of ingenuity to not only come up with these ideas, but to actually develop them and execute them in a mass-produced way.
And then automotive.
Yep.
And Shoei and Nanosys collaborate?
Yep, we started collaborating in 2019. Shoei's amazing manufacturing company. And they became interested in making quantum dots themselves. One of their other business lines is making materials for multi-layer ceramic capacitors. And the smaller they can make those materials, the better the performance. And I think you could ask them, but I think they were thinking about making quantum dots as a way to understand how can we make some of these other materials we make even smaller and even better, right? They were interested in quantum dots as well, and they had some great results actually. They did an amazing job with indium phosphide. I think 31 nanometer full width half max, which is a big breakthrough. So we called them up and said, hey, that's pretty good. Maybe we should collaborate. Pretty quickly things evolved from there, and we realized they would be a great manufacturing partner for them. So we started having them make some of our materials, and things went from there, and they bought us in 2023.
Market went in a good direction in the last few years.
Market went in a good direction, and we realized having that manufacturing closer to the customers was really valuable.
Actually, COVID was great for you. I'm joking about that. So many people bought TVs there.
So many people bought TVs, and we're still kind of living through the, that bar on the chart still sticks up, right?
It's
2021 was a huge year for the display industry, yeah. Just so much pulled in demand. But now we're seeing demand cycles return more to a normal mode, I would say, and return to growth.
And there was already NanoLED in 2020?
Yeah, 2020. BOE demonstrated a TV with NanoLED, and that was one of the first demonstrations. First smartphone was from Sharp in 2022. And then here we are, 2024. Yeah, Nobel Prize, of course.
All right. And in January, begins operation. All right, so it's going to be exciting to see the next, mass production happening with those new NanoLEDs.
Yeah, absolutely. Yeah, I can't wait to see those products in the market. But it's an amazing milestone this year again with the Blue Lifetime breakthrough, and you start to see these really good prototype demos.